Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So far we have seen the closure property and commutative property of whole numbers in the previous two videos. I hope you enjoyed the concept and you understood it so that you can implement these concepts in both real life and also in your further maths problems. So in today's video, we will be seeing in depth about associative property of whole numbers. Apply the associative property under all the operations that we know, that is addition, subtraction, multiplication and division. Okay, so without wasting any more time, let's jump right into the video. Let's see what associative property actually means. Let's say A, B and C are three whole numbers. Here assume A, B and C as whole numbers. Then associative property says that if we group together A and B and then add C, then this value will be equal to A and B plus C. A, B, C are nothing but some whole numbers as 1, 2, 3 or 0, 1, 2 or any numbers for that matter. So, whenever we take A, B, C as three whole numbers and we group them together and perform an operation on them, then A plus B plus C is equal to the value that you get after grouping them and adding them together should be equal to the value that you get after grouping them in a separate way and adding all these together. Okay, so this plus can be like this also. It can be a minus also. It is not necessary that it should always be a plus. It can be multiplication also. And it can also be division. But please remember that for a few operations only, this property is valid for whole numbers. Okay, so this property does not exist for subtraction and division. We will see now in depth why, but it definitely exists for addition and multiplication. Okay. So we will see all these operations now and see whether it's defined for these operations and it's applicable for these operations or not. So now let's jump right into the associative property of whole numbers under addition. So now let's see associative property of whole numbers under addition. According to this property of whole numbers under addition, it says that no matter how you group these numbers together and add, you will get the same result. The order of which they are grouped doesn't matter. Okay, let's see in detail. So now I have three numbers, basic numbers 1, 2, 3. Okay, now I would like to see what is the value of 1, 2 and 3. What I'll do is if I group them together, 1 and 2 together. Remember, this is called one unit. That is, the numbers that are written inside the parenthesis. This is nothing but parenthesis. The numbers that are written inside the parenthesis are grouped together, and this entire grouped parenthesis that consists of numbers can be called as one unit. It says that this is equal to this. That means if you consider A as 1, B as 2 and C as 3, then if you add A and B together and add C, the value is equal to A, and then if you add B and C together and then add to A, it is also equal. That means what is 1 plus 2? First we'll add this in the group 3 plus what is remaining? 3 is equal to, what is remaining here? 1. And what is this? First we'll add this, 5. So is 6 is equal to 6? Yes. This is the associative property of whole numbers under addition. Okay. You consider A, B and C as 1, 2, 3 in this scenario, then no matter how you group them, the result should be the same. Okay. So this is nothing but A plus B plus C is equal to A plus of B plus C. These two are two different units. Okay. Now let's see how we will group them together and apply this property on several different combination of numbers. These you can find the combinations using your own numbers, but remember they all need to be a part of this set. W is equal to 0, 1, 2 and so on. That means simply we are saying that they all should be whole numbers. Okay, and in here A, B, C are whole numbers. Okay, now let's take this combinations. First combination is, I'll take 0, 15 and 5. So first what we are doing, we are grouping 0 plus 15 and then we are adding 5. There is nothing but 15 plus 5, that is 20. Right. Now let's see by adding 15 and 5 first and then adding 0 to them. 15 plus 5 is 20. It is nothing but 20. So is 20 is equal to 20? Yes. So that means associative property exists for this set of numbers. Now I take combination 1, 0, 1. First we'll group this because every time this is the only difference between natural and whole numbers. Let's take 0 in any case that is possible. So we'll get 1 plus 1 is 2. Right? Now what we'll do, we'll just group this and add. So we get 0 plus 1 is 1. This is also 2. So that means 2 is equal to 2. Done. Now let's take a bit of a 2-digit number. 35, 45, 53. Okay. So let's add 35 plus 45 first because A plus B and then 53. You get 80 plus 53. You get 133. Right? In the same way, 35 plus 45 plus 53. You get 35 plus 45 plus 53 is 98 and you get 133. So here 133 is equal to 133. So we've tried these many possibilities and we can happily conclude that associative property holds true for whole numbers when we do addition. Okay, and remember this is unit, that is the digits in the parenthesis, and ABC must be whole numbers. So associative property of whole numbers under subtraction. Let me tell you before I start, subtraction of whole numbers is not associative. Let's prove that. Trust me, A and B and C should be whole numbers. I'll take numbers like that only. I'll start from 10, 5 and 2. Okay. Now, first what I'll do, I have to group 10 and 5 and then subtract 2. That is 5 minus 2, that is nothing but 3. Right? Then, is this? Because here B is 2, B is 5, C is 2. So 10 minus 3, it is 7. Is 3 equal to 7? No, that means associative property does not satisfy for subtraction. In the same way, let me try to take 0, 5, 5. Okay, here only you will see. 0 minus 5 minus 5. It is nothing but minus 5 minus 5. Minus 10. Let's see. Next is what? 0 minus of 5 minus 5. Here we are getting 0 minus 5 minus 5 is 0. So answer is 0. Is minus 10 equal to 0? No. So this does not satisfy. So in short, taking these two examples, we can say that the subtraction of numbers is not associative. That is, A minus B minus C is not equal to A minus of B minus C. Okay. So associative property under subtraction does not hold true for whole numbers. Now let's see the associative property under multiplication. So associative property of whole numbers under multiplication states that no matter how you group these 3 or more numbers, you will get the same result. It's like addition. Okay, let's see how it is done. So it want to say that if you take A, B and C are 3 whole numbers, then A into B into C is equal to A into B into C. This is what associative property of whole numbers under multiplication states. Okay, this is what we will be proving now. So 2, 5, 10. Now what should I first multiply? 2 into 5 and then into 10. So it will become 10 into 10, which is nothing but 100. Right? In the same way, let me try this. 2 into 5 into 10. That is 2 into 50, that is 100. True, because 100 is equal to 100. See, associative property holds for multiplication and addition because they both are correlated. Now let's see 3, 7, 5. Okay, now 3 into 7 into 5 is 21 into 5. It will nothing but 11105. Right? Now 3 into 7 into 5. It is nothing but 3 into 35. It is nothing but 105. So it holds true. No matter what the numbers you take, it still holds true. Associative property does not hold true for the division of whole numbers. So let's see how it will work. 8, 4 on 2. Let's take 3 numbers 8, 4 and 2. If I try to divide 8 divided by 4 divided by 2. What will I get? 8 divided by 4 divided by 2 is 2. So 8 divided by 2 is 4. This is 4, 2 2s are 4, no? Like that. Now here, I'll first divide this and then divide this. What is this? 8 divided by 4 is 2. Then 2 divided by 2 is 1. So is 4 equal to 1? No. So associative property does not hold true for division. Let's take another example. Take 12, 6 and 3. Okay. Now 12 divided by 6 divided by 3. So answer will be 12 divided by 6 divided by 3 is 2. 12 divided by 2 is 6. Now it will be 12 divided by 6 divided by 3. So 12 divided by 6 is 2 divided by 3. We will get 2 by 3. 6 is not equal to 2 by 3. So associative property does not hold for division. Okay. So we can clearly say that associative property is not true for division of whole numbers. Hence, we can say that A divided by B divided by C is not equal to A divided by B divided by C. That is, associative property does not hold true for whole numbers. Okay, it holds true for addition and multiplication, but it does not hold true for division and subtraction. So with this, we have come to an end of our video today. I hope you understood the concept of associative property very clearly. So if you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. So till then, I hope you all stay safe, stay happy and have a wonderful week ahead. So the puzzle of the day and the previous puzzle solution will be as follows. Bye.